Welcome to AP Statistics. In this video, we're going to talk about collecting samples in a flash. Everything you need to know when it comes to how to select a good sample. First, let's start off with collecting data. Why do we even do it? The goal of any study is to collect data to tell us something about the larger population from which the data was collected. Duh, we want to know something that's true, so we collect some data to try to figure it out. A population parameter is a term we use to identify any piece of information that is from a given population. For example, the true proportion of all teenagers that use a cell phone, or the true average mean height of all teenagers, right? Something that comes from all of the teenagers. That's a population parameter. A sample statistic is any piece of information that is from a selected sample. Here's the idea. It's quite simple. There is a true population parameter out there somewhere. Again, maybe it's the fact that there's a certain percentage of kids that own a cell phone, or maybe there's a true average weight in pounds of a huge population of students. Well, we want to try to find that value. Now, we could do a census and measure everybody in the population, but that's usually pretty tough. So we do a sample, and from that sample, we get a sample statistic. Now, that's really the same form, right? In that sample, we're going to get a proportion of kids that have a cell phone, but that's in our sample. Or we're going to get a mean weight in pounds of the kids in our sample, but it's still a sample. Even though it's looking for the same thing, the idea is the population parameter is this big value that's kind of unknown, that's true for the entire population, and what came from our sample is some data that we actually do know. And our goal is to hopefully, from that sample statistic, get really close to that population parameter. Now, there's this idea of sampling variability. Sampling variability is quite simple to understand. It says, hey, listen, no sample is going to match the population perfectly. Why? Because it's a sample. It's not everybody. But we want to get as close as we can. And if we do things that are intelligent and smart that we're going to quickly talk about in this video, we will get super close. But if we fall really short, or maybe we overshoot the population parameter, then we probably have some type of bias going on. But the idea is to use our sample statistic to try to get a really good estimate of that population parameter. Now, once again, how do we do this? Number one, we could conduct a census, but oftentimes if the population is really big, it's really costly and time-consuming to do that. Or we could select a sample that is random, representative, and truthful to give us the most accurate estimate of that population parameter. All right, so now that we understand why we select samples and what we're trying to do with the sample, let's talk about how to get a sample. 3 basic rules. Every good usable sample must be random, representative, and truthful, meaning it cannot be filled with bias. It's got to be unbiased. So what are the ways to select a random sample? Because it's got to be random, right? So how do we make sure we do that? Well, 4 ways to select a random sample: simple random sample, stratified random sample, cluster random sample, and a systematic random sample. Now, a simple random sample is you basically got your entire population. Everybody in your population gets a number or somehow gets labeled, and you use a random number generator or some type of generator to pick the sample out of that population at complete randomness, right? So you got your population, you find a cool way. It's usually pretty simple steps. Step 1, everybody gets a unique number. Step 2, ignore repeats, ignore numbers nobody has. Step 3, use that random number generator to select your numbers, and boom, find the corresponding people selected based on the corresponding numbers you gave them. Nice and simple, right? Stratified is when we first take that population and break it into groups based on a variable that you think is pretty important. Then you take a couple people randomly from each group to create your sample. How easy is that, right? This becomes your sample. So essentially, in my little group here, you're going to do 5 simple random samples, because you got to go to this group, take out a couple people. 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 That's a stratified random sample. That's going to really guarantee you some nice representation. But the most important thing is, how are you creating those groups? What variable are you using to create those groups? You're using a variable that you think matters to the larger value that you're trying to figure out, right? So you got to really think about what is the parameter that we're trying to find and how can we more accurately get it. If we want to guarantee representation based on another variable, that is why we stratify. We'll talk a little bit more about that in a minute. Another way that we can select a random sample is by a cluster random sample. That's where you take your population, you break it down into groups, and then here's the kicker, right? You don't go to each group, you label the group. So this is group 1, 2, 3, 4, and 5. And then you use a random number generator to select 1 or 2 of those groups, actually could be more than 2, to become your entire sample. So maybe 4 gets randomly picked and everybody in group 4 becomes my sample. We really only want to do a cluster random sample when these groups, for example here, these 5 groups are already like mini populations. So if these groups are already nice mixes, so group 1 is a nice mix, it's truly mixed. So if it was picked, it's going to be representative. Maybe group 2 is also a really nice mix. Group 3, 4, 5. Essentially, each of your groups is very diverse within. So if it gets picked, you'll have that diversity and representation that you want. A systematic sample is maybe where you get a list of all of your people and you randomly go down on that list and you select every 5th person. So 1, 2, 3, 4, 5, congratulations, you're picked. 1, 2, 3, 4, 5, congratulations, you're picked. That's how you do a systematic random sample, is when there's pretty much a system to it. I'm going to select every 10th person. I'm going to select every 8th dog, whatever it is. So those are the 4 different ones that we use to select a random sample. Now, let's talk about a really important question that you're probably going to be asked. Why do we stratify? Why is it important to sometimes stratify? So if we are concerned that a simple random sample might not give us representation of an important variable, we use stratification to guarantee that representation. So once again, let's say we have our population, and maybe our population is a mix of boys and girls. And if we do a simple random sample, we might get all boys. I mean, maybe it's unlikely, but it's possible to get all boys. But if you're like, oh man, I can't have that happen, that would just ruin everything. I need boys and I need girls. That's when you go ahead, split up your population to boys and girls. Go to the boys, randomly select some out. Go to the girls, randomly select some out to create your sample. Now you're guaranteed that representation. By creating a more diverse and representative sample, it will reduce the variation for the parameter we are trying to estimate. For some students, that's really hard to understand, but this is a really important sentence right here. So think about this. If we did a simple random sample and maybe we got all boys, if that could lead to bias, right? Remember, don't forget, we have that parameter. We talked about this in the very beginning of this video. We have a parameter and we're trying to use a statistic from a sample to estimate it. Well, if you are afraid, oh no, if I get all boys, my statistic might be way lower than the parameter or way higher than the parameter. It's not going to give me that accuracy. Well, okay, I need a mix of boys and girls. Why? Because the population has boys and girls. So my sample should have boys and girls. So I'm going to stratify to guarantee a sample that's mixed up with boys and girls. That is going to be a more diverse sample, but because my sample's more diverse, like my population is, I'm actually going to get closer to the parameter I'm trying to measure. So that's why we say having a more diverse, having a more representative sample, if you can guarantee it with the stratified sample, will reduce the variation for what it is you're trying to measure. If what you're trying to estimate is something that pretty important to have boys and girls in it, then when you have boys and girls, yes, you have a very diverse, representative, mixed up sample, but because you have that diversity, you're actually going to get closer to what it is you're trying to find. Here's a quick example just to kind of make sure everything makes sense here. A college has 12,000 students, and we want to get a sample to learn what proportion of students feel a new campus union is needed. So we're looking for this population parameter, the percentage of kids that really want a new campus union for whatever reason. Well, we don't have time to do a census to get all 12,000 people, which would lead to a parameter, but we do have time to get a sample. So if we do a simple random sample, every kid gets a number, and we're going to use a random number generator, ignore repeats, ignore numbers nobody has, and maybe the first 200 kids selected will be asked, hey, Do you feel that we need a new campus union? That's going to be a simple random sample. Easy, easy, easy. Now, a stratified is when we say, oh, wait a minute. There's something about my population. There's some characteristic. There's some variable in my population that might make people feel differently about this new campus union than maybe others. That variable could be gender. Maybe boys and girls feel different. So you want to guarantee a mix of gender. So you separate your population of girls and boys, take some from each, creating that stratified sample. Again, it's going to be now mixed up. Maybe it's grade level. Maybe it's freshmen, sophomores, juniors, and seniors. You think that, seniors probably don't care. They're on their way out. Freshmen are brand new. Yeah, they want a new campus union. And maybe sophomores and juniors might feel different. So you break your population into freshmen, sophomores, juniors, seniors, and then you select a couple from each to make your sample. This is going to guarantee us representation for a variable that we think matters. And because our sample now is guaranteed to have that mixed up group, that representation, we're actually going to get closer to the true percentage that we're trying to estimate. Next we could do a cluster sample. A cluster sample would, typically we do a cluster sample when groups are kind of already created, right? So, maybe we have dormitories. We have dormitory A, B, C, D, E, F, G, H, I, J, K. And each dormitory is a mix of freshmen, sophomores, juniors, seniors, boys, girls, this, that. The dormitories are like mini populations. Then we make it easier on ourselves to label the dormitories. We don't have to label the kids and do a bunch of random samples. I don't even know if I counted all those right. Sorry, I might have forgot a number. But here's what we do. We then label them, and then we use a random number generator to pick one of the dormitories. Hey, congratulations, dormitory 6, you're picked. And everybody in that dormitory becomes our sample. Now, as long as there's no reason to believe that dormitory 6 is different than any other dormitories, we're going to get a nice mix of boys, girls, freshmen, juniors, sophomores, seniors, good kids, bad kids, smart kids, rich kids, poor kids. But again, if you feel that, whoa, dormitory 6, that's not representative, they're very different than dormitory 11, then don't do a cluster sample. Go back to Stratify, it might be better. Lastly, is that systematic? Maybe we get a huge list from the dean's office of all the students, and we randomly start here, and we take every 15th kid on the list. That's going to be systematic. All right, what do we not do when sampling? Because everything we just talked about was good ways to make it random. What do we not do? Well, we talked about what makes samples good, random, representative, truthful. So anything that leads to those things not happening, that's going to be bad. Selection bias is one way that this could happen. Selection bias is selecting a sample in such a way that it's not random, not representative. Well, if you're not random, not representative, not going to be a good sample. Survey bias is your survey is conducted in such a way that it will not get truthful responses. Whoa, wait a minute. Our responses aren't truthful? That's going to lead to bias. That's not going to give us a good estimate for what we're looking for. Don't do it. There are a couple different forms of selection bias. Number one, volunteers. Anytime you ask volunteers to give their responses to you, you're typically going to get really strong, or, you're going to get the kids on, really strong one way or the other. You're not going to get a good feel for your data, so don't use volunteers. Convenient sample is simply not random, doing something that's convenient. Like just using your friends for the sample. That's not going to lead to accurate data. And anything you do that might lead to under or over coverage bias. So for example, if you select dormitory 6 because you thought it was a good random sample, but all of a sudden no freshmen were in dormitory 6, now your method that you thought was good completely undercovered freshmen, overcovered everybody else. That's not going to lead to a good sample. Survey bias is something is wrong with how you ask your questions. Comes in two forms. Non-response bias. Non-response bias is when 200 kids are selected to be in your sample, but some of them don't respond to you. And you can't just allow them to not respond. You got to get their responses. So you call them, you give them incentive, you email them, you bug them. But if you allow people chosen to not respond, there might be a big difference between them and those that do respond. And if you don't establish that difference, now your sample is actually not representative. You've created a sample that's different than what maybe the truth is. Response bias is when anything is wrong that could cause a person to not respond truthfully. So this could be the wording of the question. Maybe your question is, hey, the current student union is terrible. It's falling apart. Everybody hates it. What do you think of the student union? So I worded that question to try to get them to say yes. Or maybe the interviewer could be biased. Maybe you have the dean of the college directly asking the questions one-on-one. And somebody might be like, I don't want to lie to the dean, so I'll just say, yes, I want a new student union. Or maybe you're doing some type of measuring to get your data. Maybe it's a scale or tape measure, but it's broken, so all of your data's wrong. Maybe it's peer pressure. Maybe I'm in a room and everybody else votes yes. They're in favor of the student union, so I feel like I guess I got to vote yes too. That could lead to bias. Those are all bad things. All right, that was like a really quick flash way that we can quickly talk about what is good and what is bad when it comes to sampling. Hopefully it all made sense, and I'll see you later.